generation and consumer loads through various switchyards, substations, and switching stations. So all together they make a grid. And OpenSS is a different thing. We will talk separately. OpenSS means that anybody should be able to use this grid for drawing power. As on today, you have to take a permission from the various discoms to draw power from anywhere you like. Otherwise, most of the time you are connected to the discoms. So we will talk about first grid code, and then we will go to the OpenSS system. Our point will be same as we had last time. If you have any question, you can simply ask. You can unmute yourself and ask your question, and I will try to answer to the best of my ability. So what we will discuss today is why do we need grid energy management, institutions, organizations involved in grid energy management, what is Indian Electricity Grid Code, what is the role of various organizations and their linkage, transmission connection code for interstate power flow, grid operation code, and last we will discuss OpenSS. I think I have not written, I'll just write it here. OpenSS. Right. So grid energy management is, as I told you, that we have to ensure that whatever we are generating gets transmitted safely to the end user without overloading the transmission line or without getting any congestion that the transmission capacity is not available, you are not able to supply the power. So all the transmission lines which are interconnected, initially the Indian system was operating on regional basis, northern region, western region, southern region, eastern region. Now also we operate on regional basis, but all these regions are now connected through the AC and DC transmission system, which is around 1,10,000 megawatt, which is quite substantial. That means 25% of our power can flow between the regions very smoothly without any problem. So there is a company called POSOCO who manages everything. Earlier it was Power Grid. Power Grid was doing the POSOCO function as well as this. POSOCO is Power System Operating Company. POSOCO. It is a separate entity now. It has been separated from Power Grid basically. So energy management basically requires safe and reliable operation of grid. There should be no congestion, no problem, no tripping, and you should have a capacity for little over drying also, overloading also. Because once a load is connected to the system, you cannot control its load. Otherwise, if the load increases, you all know that if the load increases, generation is less, the frequency will fall down. So we have to increase the power again. Suppose the generators are not able to increase the power and load goes up, there could be a lead. This could lead to a failure of generators. The generators can go out of synchronism. So that is why it is required that whatever the various constituents, I will say constituents means the various states who are drawing power from the grid and feeding into the grid shall maintain itself within their entitled limit. They should maintain discipline. There was a time in 2011-12 when that discipline was broken and the entire country plunged into darkness. There was a total grid failure. So after that, a lot of precautions have been taken, and the grid code, the grid management, energy management rules have been made very stringent, and people have to follow this. If someone is found not following, there is a huge penalty on that. So trouble-free operation, real-time matching of demand and supply, because electrical system, whatever you generate has to be used. You cannot store it. Storing you can do in the battery, a little bit of it, or in the pump storage system. Now the hydrogen storage is going to come. That's a different part. Otherwise, whatever you generate has to be consumed. Consumed means either it has to be consumed with the industry load, domestic, commercial, or it is to be stored in the battery. If you don't generate, it is wasted. That's all. And when you are transmitting this power, so you have to maintain the voltage and frequency of the grid within tolerable limits. The voltage and the grid. So if the load increases, if the reactive power increases, then the voltage goes down. You might have read about the transmission, about the generation system, how the power system, how the generator, large thermal generators generate power or hydropower generates power. Basically, when you increase the steam input to a generator, you are increasing the active power. More steam input into the generator, you are increasing the active power. That means you are stabilizing the frequency. And if there is a demand in the reactive power in the system, if you have a load which has a low power factor and demands more reactive power, then it will reduce the voltage. And then that voltage has to be built up by feeding more excitation system. You have to increase the excitation system by using AVR, automatic voltage regulator. That is a system which is used in the power station to match the demand and supply. But there is a limitation on supply. If I have a 500 megawatt generator, I can maximum go up to 525. Continuously 525 I can feed, but I cannot go beyond. So somewhere demand also has to be matched. So demand response is very important. Nowadays, the various organizations which we'll be discussing subsequently maintain a close watch on the power being drawn and the power allotted to various states. So they try to keep a match. If they don't do, they switch off the breaker. The only way to manage demand is to cut off the supply, cut off the breaker, nothing else. You cannot ask him to reduce the load. Either the industry has to stop, or you have to cut off the transmission line either at 220 kV or at 132 kV. That is what can be done, nothing else. And voltage and frequency, as I told you, can be maintained through active power management by putting more steam, more active power, and through by increasing the excitation system by maintaining the reactive power by voltage and frequency. Then integration of renewable energy with the grid is becoming a major issue nowadays. You know that in India we have around 400 gigawatt installed capacity, out of which 100 gigawatt is renewable, little higher than 100 gigawatt. So that means around 25%. But in energy terms, it is less than 10%. You know that in case of thermal and hydro plants, you can get PLF of the order of 80%, 85%, 90%. But in case of wind and solar, the CUF is order of the in the case of solar, the PLF or CUF you call coefficient of utilization factor, coefficient of utilization factor CUF. That is of the order of 20 to 21%. In most of the places, it is even less than 20%. But 5-6 places in the country, it goes up to 23 to 24%. Which is, you know that there are 5-6 regions in the country which has a very high wind and solar potential, where there is a good concentration, which are Gujarat, Rajasthan, Andhra Pradesh, Tamil Nadu, Telangana, Maharashtra. These are the 5-6 states where you have the good concentration of solar as well as wind. So once this capacity goes beyond 10%, then the renewable power has to be used because it is a must run station. So what? Just a minute. Hold on. Just a minute. Hey, Usha ji. Hello. Hello. There was environmental noise you might be hearing. So I thought I must cut it off. So once this renewable capacity concentration in the grid increases, and why it is uncertain? Because there is a total uncertainty about the availability of solar or wind. In a fraction of seconds, the entire wind power generation can be reduced to zero, or the solar power generation can be reduced to zero. So to maintain the grid stability, if the generation goes low, load is there, everything will fail. So all these thermal stations and hydro stations have to ramp up very fastly, very quickly. So the CERC, Central Electricity Regulatory Commission, is coming out on time to time with various guidelines, with various regulations, that these thermal power stations have to have a ramp up requirement of a certain megawatt per minute. I think it is 5%. They should be able to increase the capacity per minute, ramp up. Then only the grid will become stable. Now they are also, because this thermal station cannot be switched on immediately. Only gas can be switched on, hydro can be switched on, thermal cannot be, but our thermal capacity is very large in the system. So they are now basically keeping some thermal station as a reserve capacity. They will not be feeding to the system, but they will be available if there is a shortfall in the power supply in the system and load is more. And that shortfall can come only because of failure of availability of renewable power. Now, to ensure to have the certainty about the renewable power, the CRC in its regulation has come up with which is called forecasting techniques. So they have a requirement of forecasting the power which you will be giving us tomorrow. There are now artificial intelligence and machine learning tools are available, which are using the weather conditions and the mast data, wind mast data, and they are forecasting that tomorrow what will be the energy available from solar plants or the wind plants. As of today, we are able to do this prediction at a plant level, at a regional level, but it is possible that tomorrow we will be able to do at a solar panel level, at a locational level. Today it is at a regional level, and every state has made it mandatory. So if I have a solar plant or a wind plant, I have to tell that tomorrow from a 100 megawatt solar plant, how much energy means not megawatt, million unit, how much million unit I will be supplying. But considering that nobody can have a good prediction of the weather, there are flexibilities provided that this wind plant and solar plant owners can revise their schedule during the day, but giving a notice of 1.5 hour at a notice of 6 time blocks. When I say 6 time blocks, you know that Indian power system is divided into 96 time blocks. So 24 hour, every block is of 15 minutes. So 15 minutes into 96, you get 24 hours. So 6 time blocks means 90 minutes. So solar and wind people can revise their power output based on the weather conditions 90 minutes in advance. If they tell in 90 minutes advance, then they will not be penalized. If they don't tell, if they produce power less than what they had committed and they don't change their forecasting, then there is a huge penalty. These are the various conditions which are coming for having a seamless integration of renewable energy with the grid. Otherwise, these renewable energy, which is must-run station, and the thrust is going on from 175 gigawatt to 500 gigawatt by year 2030, the grid maintenance is going to be a big problem. So that's another area where the grid code adherence is very much required. Then facilitate the functioning of power market and ancillary services. How the power market has to function. There are many people who needs power during the day because demand may go up. There are many people who are not able to supply. So the power market has two components. One is trading and other is the power exchange. Like PTC, from which I have retired, as a power trading corporation, is into trading as well as help people to buy power from the exchange, which is IEX, India Energy Exchange, Hindustan Power Exchange, PXIL. There are 3 exchanges operating in the market. And the various states are the various large companies who wants to buy power directly from the market. They can buy power from the market, and the exchange gives you flexibility to buy power of a given quantity for every time block. You can say that for time block 1 I need 100 megawatt, and for time block 2 I need 60 megawatt. If your process is like this, you can bid it, and you can during the matching engine you can get allotted like that also. But if you many people who are in the process, who run for 1 shift or 2 shift, are now shifting to the power market depending on the prices. And then the trading means that you can buy power for 1 week, 1 month, 3 months, 1 year. Up to 1 year it is called short term power. Then 3 to 5 years it is called long medium term power. So you can manage that. So that is a functioning of power market. That suppose why it is coming is, suppose as a state, I am a UP state, my power requirement is 15,000 megawatt. It has increased, but my available capacity is only 12,000 megawatt. So I'm a short of 3,000 megawatt. So either I will do the load shedding, I will cut off the power supply to various regions by rotation, or the political willpower is no, we have to give 20-hour power supply, 24-hour power supply. Then I have to buy this 3,000 megawatt power from the market. This power from the market can be produced for any time duration you want. Nowadays, it has come on a real-time market segment has also come in the exchange, that you can buy power for every half an hour. You have to bid in 1.5 hours in advance, and you can buy power. Like you want additional power at 12 o'clock in the night, you have to give your bid for 10:30. Within 1.5 hours, the exchange will do one calculation and see what is the availability of the transmission system, and then they will supply you power for every half an hour. So that is a continuous process.